You are watching the 2.7 video on key features of functions, and this is the second day of these notes. So a lot of it is going to be repetitive. It's just a pretty big topic, so we like to spend 2 days on it. But let's take a look at some of these examples. Exercise 1 is done for you. We need to find the values of each of the following. So f of 4. So if f of 4, what they want us to do is find when x is 4. So 1, 2, 3, 1, 2, 3, 4, which is this value here. And I had to go up 1. Same thing here when x is negative 1. So x negative 1, we have to look up 1, 2, 3, 4, 5, 6. So that's a point negative 1, 6. These are just points. You could also write them as 4, 1, and negative 1, 6. That's not what it was asking you for, but that's just what it is. For B, for what values of x does f of x equal negative 2? Well, in this case, we are given the y value of negative 2, which means we need to go down to negative 2 and then look left or right. That's what this blue line is here. Where does it hit? Well, it hits at these two x values. If it's easier for you to see, we could just lift off the point as 1, negative 2, and 3, negative 2. Notice we're just looking at the x values for the y value of negative 2, which is 1 and 3. And minimum is how low can you go? Negative 3, this guy right here. And maximum is 6. Because there's not arrows, this only goes up to 6. In D, it's in red. Draw and label the axis of symmetry. It's this guy here. It's what makes the graph cut in half. If it is a, actually, axis of symmetry labeled will always be x equals because it's always going to be crossing the x-axis. In this case, crosses the x-axis at 2. Okay, moving on to exercise 2. Let's do this one together. All right, so we need to evaluate each of the following: f of negative 3, f of 1, and f of 3. So remember, in the parentheses is always the x values. The number that we get out is the y. So we input x, output y. So if x is negative 3, so negative 1, 2, 3, we're either going to look up or down, and we had to go up 1. Another way of looking at it is that is the point negative 3, 1. All right, f of 1. All right, we either look up, nope, or down. We had to go 1, 2, 3, so negative 3. And then the last one, when x is 3, so 1, 2, 3, I have to look up 1, 2, 3, 4, 5. Again, another way of looking at it, it's a 0.35. When x is 3, y is 5. Okay, so B, can the function rule given by the graph give you a value when x is equal to 5? Let's check it out. 1, 2, 3, 4, 5. I look up, I look down. Is there any graph to be found? No. So can you get a value? No. Why not? The graph, or the graph's domain, let's talk about that. The domain is from what? Let's see. Negative 1, 2, 3, 4, 5. So from negative 5 all the way up to 1, 2, 3. And x is 5. Therefore, not in the domain. Okay, is x equal 5 in the domain of the function? Oh, we already just answered that. Nope, no, no. All right, it says write the domain and range of this function using a single inequality. Oh, well, this is cool. We just did the interval notation. So that was our domain. Let's use this down here. So this goes from negative 5, oops, not a comma, less than or equal to x is less than or equal to 3. And the range, well, let's see, how low can you go? Looks like there. To how high can you go? All the way up here. So what is that? 1, 2, 3. So that's -4 all the way up to 1, 2, 3, 4, 5. And both of those points are closed. So therefore, -4 is less than or equal to y is less than or equal to 5. Okay, so here we have parent functions. And we have not yet talked about those parent functions. So, what do I want to do first? You know what? Let's go through and label what all of these are because it says we need to label them. So first we need to label them with like what they're called, their parent name. And then using our calculator, we're going to graph and then fill in the table of values. And you know what? I'm going to leave that up to you, and then we'll reconvene at the end of this video. Okay, so first let's label. This first one here, you guys should know what this is. This is a linear function. The one to the right that makes a v is an absolute value. Okay. Heading on down, this is a quadratic, also known as a parabola. This one to the right here, x to the third power, this is a cubic function. Here is, well, this one's pretty straightforward. It's a square root function. And this one is a cube root function. And this little guy here, it's really hard to tell, but this looks like this. I'm just going to trace over it. This is an exponential. Okay, so I'm going to pause the video and just fill all these in. And you're going to pause the video and then you are going to use your calculator to fill in all of these tables here. If you don't have your graphing calculator yet, you can, I think desmos.com, DESMOS.com might be helpful, but really I would say using your graphing calculator is the best and most efficient and easiest way. Remember, in order to see the table, you have to hit Control and T, and then use your up and down arrows to get all the points you need. Okay, check it out. Here's a table for linear and absolute value. Here are the tables for the quadratic and cubic function. Square root and cube root. In your calculator it would have said undefined because notice how there's no graph in the negative area. It's a good point to bring up. The domain is always restricted with a square root function. Cube root. And lastly, exponential. Hope you did great. Make sure, I would say the biggest thing that you should have gotten from doing this activity is knowing how to type stuff in on your calculator and graph it. If you had trouble, make sure you let us know. Just knowing the names of the functions. Like when you look at this, you should be like, yes, that's an exponential. Or if you look at this one, you're going to be like, yes, this is a quadratic, it makes a u. Or yes, this is an absolute value, it makes a v.